we also completed this the effect of forces between bodies, such as changes in the speed, shape, or direction. Identify different types of force, such as gravitational or electrostatic. Okay, so understand force is a vector quantity. Calculate the resultant force of that act along a line, and know that friction is a force that opposes motion. Okay, all right. Hamza, did I discuss this? Know and use the relation between unbalanced force, mass, acceleration, F is equals to ma.
No.
All right, okay, fine. So types of force, such as forces, such as gravitational force. Okay, let me share the screen, and we are going to start. Gravitational force. Okay. So do you believe that gravitational force in reality, does it actually exist as a force? Do you be
Uh, as, as a force, yeah.
Yeah, do you believe that gravitational force itself it exists as a force?
Yes, yes.
Okay, right. Okay. So I will ask you to refer the history of gravity. Okay. Okay, so
Yeah.
you need to refer history of gravity, right? So that will give you the idea that is gravity a force actually, or is it a effect? Okay, is it a kind of effect, or is it actually a force, right? But over here, I'm going to, refer it as a force. I'm going to consider as a force. Why? Because our syllabus, our textbooks are demanding, okay, to keep this in the category of force, right? Okay. All right. So gravitational force is nothing but a force. The force the force um the force that that is due to mass per gravitational force, right? Okay. Mass per gravity. Gravitational force is the force due to mass per gravity. Number one. I can call this in this way: mass over strength of gravity. Strength of gravity. Okay. So gravitational force exists due to the masses, right? Gravitational force exists. It exists due to the masses, right? Uh, for example, if you have one object and if you have another object, right? So this object is M1, this object is M2. So both are, exerting force along a direction, along a line that joining their centers. The force, where the force is acting, is it is it anywhere? Is it anywhere? Is it
No.
anywhere? Or they are applying force along a direction, along a line of that direction, or along a line that meets the center of the two bodies. Okay. So that is this concept of uh, gravitational force, it was given by Newton's, right? So Newton's gravitational law. Have you heard about it? Newton's gravitational law.
Yeah, I've heard about.
Okay, so the force between the objects, right, is actually directly proportional to the product of their masses, right? Product of their masses. And this force becomes weaker if the objects are far apart, right? If the distance between them is greater, the force becomes weaker, right? So we can combine these two statements in one statement or one mathematical expression, and that is Gm1 m2 over r squared, where this G is the universal gravitational constant, universal gravitational constant, and this value is constant everywhere, and the number of this value is 6.67 into 10 to the raised power minus 11 Newton meter square per kg square. This is constant everywhere. And this force does not depend on the medium, right? The gravitational force does not depend, gravitational force does not depend on a medium, right? So why we are not saying that it depends on medium? Because when we say medium, so there must be a different force of gravity, but the force of gravity varies as masses are, different. If the masses of the bodies are going to be different, then the force of gravity would also be different, right? For example,
Can you repeat? Can you repeat?
for example, for example, sun is a massive object, right? Sun is the massive body, right? So it has huge strength of gravity, right? So
Yeah.
sun being a massive object pulls object towards its center, okay, right? And it is due to the massive body, right? Massive mass. Okay, so the mass of sun is 270 times greater than mass of Earth. Okay, right? That's why we can say the strength of gravity of the sun, the strength of gravity of sun is also 270 times greater than the strength of what? Strength of Earth. Okay,
The
right?
gravity. Yeah.
Okay, all right. So gravitational force is nothing but it is the force due to the mass, right? If the object has mass, there will be a gravitational force. Okay, and the force that is this the force due to the strength of gravity, right? Gravity can be experienced can be experienced by another object, by another
Object.
object, right? Having having noticeable mass, right? Okay. So remember, this concept is, is quite different. Okay. Because many years were spent on, on the study of on the study of gravity, right? So it's that's why I have asked you to refer history of gravity. Okay, so you need to, find out different documentary on history of gravity. So you will be able to understand that how Einstein, developed the concept of strength of gravity. And Einstein believed that there is no force like gravity. Okay, it's a effect. Okay, it's a effect of uh, you know of uh, of the bending of the curvature of the of the universe, right? And how this curvature bends, it is due to the masses, right? So the effect of that bending, the effect of that bending of the curvature in the space causes the strength of gravity, right?
Yeah.
So from here you will be able to understand better. So, right, so that's why I'm referring you to to find out different research on gravity. All right. Okay, so let's talk about the electrostatic force. So what electrostatic force is? Yes. So due to different charges. Yeah.
Yeah.
Okay. So it is uh it is what should I say? Should it be always attractive force or a repulsive force?
It could be both.
It could be both. Good. Okay. So electrostatic is, it is a branch of physics, right? That deals with the phenomena and properties of the charges, right?
Yeah.
The screen is not taking the picture. Let me copy it again. Now, can you see this?
Yeah.
The electric field lines. Yeah.
Yeah.
So do you have any idea about the field? Yeah.
Yeah.
A different types of field exist, right? What is field? Field.
Uh,
It
a
could be a
place where
yeah. It could
a
be a
place where
gravitational
force
field. Uh-huh, uh-huh.
a place where force is acted upon.
Okay, so the region, right? The
Yeah.
the region or a space, good, where where another field can be experienced. Okay, clear?
Yeah.
So it could be a, if it is a magnetic field, so you will write the region or space where magnetic field, where another magnetic field can be experienced, right? And if it is an electric field, so what will you say? The region or space where another electrical field can be experienced, right? So
Yeah.
when there's a charge, so around the charge, there's always a field, right? Around the charge, around the charge, there is a field. Okay, there is a field, right? And when we say the charge is at rest, charge is at rest, right? So the field, which in which way we are going to deal in? the charge is at rest, so it's a stationary charge. So electrostatic effect will be there. Electrostatic effect will be there. Okay. So if the charge is moving, right? The moving charge always, moving charge always has a magnetic effect. Is this clear? Magnetic effect. Remember, when the charge moves, it has the magnetic effect, right? Clear?
Yeah.
When the charge is at rest, it has the uh, electric effect, okay? Right? So charge can be stored or transferred. Now, you can see here, there are two types of charges, positive and negative. So you can see the electrical lines, electric field lines, what I'm calling them? Electric field lines, electric field lines, clear? Electric field
Yes.
lines, they start from the positive and then they end up at negative, okay? Right?
Yeah.
And larger, if you can see here, this region, you can see here, this region, in this region, lines are very close to each other. The lines are very close to each other. Yes, you can see.
Yeah. Yeah.
Yeah. So the region where the lines are closer. So what are you going to decide?
Uh,
Does this region have a strong electric field or weak electric field?
from
A strong electric field. Okay. The region where the lines are closer to each other, the strong electric field will be there. The strong electric field will be there. Clear?
yeah.
Okay. So electrostatic force is due to the charges. Electrostatic force uh, is the force between the static charges, right? Between the static charges, right? And it depends on medium as well, right? Right. It depends on medium. And gravitational force does not depend on medium. Clear?
Yeah.
Are you getting my point? Did I mention this? Does not depend on medium. Over here, you can see gravitational force does not depend on medium, right? And over here, uh, it depends on medium, right? Okay, so if I say, can we have any mathematical expression of electrostatic force? So yes, K Q1 Q2 over R square, where Q1 and Q2 are the charges. Clear? Charges. Two charges are there. Two charges are there, right? One is Q1
What's
and
what's
one
K?
is, yeah, yeah. I'm
What's
I'm
K?
telling I'm telling you. This is the constant, right? This is the constant, electrostatic constant, electrostatic constant. And is this again fixed? That is 3 into 10 to the raised power 9. Okay. So Newton meter square over Coulomb square. As you can see here, if you refer this value G, yes, I wrote the number here. One number
Yeah.
here. You can see this one. Yeah, so this refers to G, capital G, and that's the universal gravitational constant. Okay. And when we talk about the electrostatic force, so there's the constant that is K. right? And this is electrostatic constant. And the value for this constant is 9 into 10 to the power 9 Newton meter square per Coulomb square, right?
Okay.
Uh, all right. So in A levels, you will study in the detail of this K and G, right? So I'm just skipping the detail of these constant of proportionality. We call them constant of proportionality, okay? Constant of proportionality over here is K. Constant of proportionality in universal gravitational law is capital G, okay? After that, we have uh, another thing that is what? After this forces, we have to understand how vector quantities differ from scalar quantities, right? How vector quantities differ from scalar quantities. All right. So scalar and vector, right? So do you have any idea about scalar and vector quantities? Scalar and vector quantities. Yes.
Yeah.
Yeah. So you can share your
Uh,
points.
I uh
The scalar
scalar.
quantities.
I know
Uh,
some
did
example
I
of
Okay, did I mention the scalar and vector quantities in the beginning of the lectures?
yeah,
Yeah.
yeah.
So
Uh,
I can recall some of the examples so that we can, complete this. Scalar quantities are those quantities uh, which which are specified with magnitude only. Okay. For example, if you want to weigh your mass, right? If you want to weigh your mass, so would you like to uh would you like to place your body in horizontal direction, vertical direction, diagonally? Does it give you different mass?
no,
No. So that means the mass does not have any direction. Similarly, so there are many quantities which do not have direction. So they come under the examples of scalar quantities. Okay, like temperature, pressure, work, and mass, temperature, pressure, work. Any other? Yes, any other quantity?
uh,
Current. Okay. Volume, right? Whatever the quantities that you want to measure, okay, so they will come under this, right? And vector quantities are those quantities which are specified with magnitude, as well as direction. Okay, with the magnitude and as well as direction, right? So for example, you move with particular direction, so that's going to be displacement, right? Okay, so we have covered these all things, right, in the previous lectures, right?
yeah.
Okay, so now they are asking to understand the force is a vector quantity. Okay, so force is a vector quantity. All right. So how can you say the force is a vector quantity? Force
Uh,
is a vector quantity. Yes. Whenever you apply a force, okay, and if two forces are acting on an object, right? So rules, vector rule of addition can be applied, to find out the resultant, applied to find the resultant force. Okay. For example, I have applied this F1 force and then F2 force on this object. So, what do you think? Where will this object go?
uh, it'll go like diagonally.
In that
Uh,
direction, let me label it A, B,
B, B, go
or C.
B.
B. Okay. So the object will have to move to B, right? So how are we going to find out the value of the resultant force? Are you getting my point? What is for example, I have applied 5 Newton force, and over here I am applying 6 Newton force. So how do you know that what is the force in the direction of B? Yes.
I,
Okay,
I
so
know.
yeah, we are going to apply the tip to tail rule. Okay, tip to tail rule. Okay, now you have to take out the pencil and the ruler. Okay, and what you are going to do is you will put one point and consider it as as an object. Okay, so I'm just dragging these forces. Let's say I have taken out this force, right? So let me paste it here. Now see, I'm applying force. Okay, the same force, the same magnitude of force I'm applying on this object. Clear? Are you getting my point?
I,
So this is your this was your F2, and that was of 5 Newton. So if I define a scale here that 1 Newton is going to be around um, 1 centimeter. Okay. Are you getting my point? Yeah.
yeah,
So what I'm going to do is I'm going to draw a 5 centimeter line. Okay. Right. Upward. And the same thing I'm going to do with this F1, right? So this is your F1, right? I'm going to join it here. The head of this F1 is going to join on the tail of F2, right? Now you must have got this idea that what I'm doing here, right? Yeah.
yeah,
So this is your F1, and that is your 6 centimeter. Okay. Is this clear to you? The same object is placed here. I have considered the object is here. Yeah. And the object is being acted by two forces, F1 and F2. And I have upon this chosen scale, 1 Newton equals to 1 centimeter. I have drawn two lines that are perpendicular. And what I'm going to do is I know that need to find out the resultant. So the resultant is going to be in this way, in this direction. Clear? Where the tip, this is your tip, this is the tip, right? This is tip to tip. Are you getting this? Tip to tip are joining and tail to tail are joining, right? Tail to tail are joining. So here's the point
yeah.
where the tip and tip are joining and tail to tail are joining. So this is your resultant vector. This is your resultant force. Okay. Now when you extend it and you meet these 2 points together, right? So now you can measure the length of this line. Can you measure with the ruler?
Yeah.
So what are you getting?
Uh,
Haven't you drawn?
I've
Okay.
drawn, but like very rough.
Okay, you need to use the ruler, right? Because 5 centimeter, you have to draw a line of 5 centimeter vertical, 6 centimeter horizontal, and then join these 2 points. You will get the resultant force, and this is how the force, has the direction, and the vector rule of addition can be applied. This is how we can, understand the force is a vector quantity. So whatever the vector quantities are given to you, they must be specified with the direction, right? And the vector addition rules can be applied. Clear?
Yeah.
Okay, so try to find out the value of this resultant.
It's around 9 centimeters.
Is it 9 centimeter?
Yeah.
Okay, so manually, if I do the calculation, if I apply Pythagoras theorem, you remember Pythagoras theorem?
Yeah.
Yeah. So Pythagoras theorem can be applied on a right angle triangle.
Uh,
So over
7
here,
point.
over here, 6 is square, 5 is square, and the resultant force cos square. So you get 36 and that's 25.
51.
So what are you getting? 51 square root
7.8.
of, yeah. So what are you getting? 7.8
Uh,
or 9?
no, no. It's 36 plus 25 is 61, not 51.
61. Okay, I'm sorry. 61. Right, take it. 61.
7.8.
Okay. So it's 7.8 is 64, 7.9. 8. Okay, 7.8. Got it. 7.8. And you were saying 9 centimeter. How can it be 9 centimeter? You must have drawn without, without ruler. Or you
No, I did.
estimated. Okay, okay. So you have to be very perfect in, making these things so that less error, is possible there. Okay. So I hope that you understand the concept of vector addition. Okay. And
Yeah.
calculate the resultant force or forces that act along a line. All right. So they are making us to understand this thing. The next LO, they are asking when two different forces or multiple forces are acting, right? For example, this is your F1 is, let's say, F5 Newton, right? And this is your F2, let's say this is 6 Newton, right? So what will be the resultant force? Resultant force.
11.
Yeah. So they can directly be added, right? So 5 plus 6 is going to be 11 Newton. Clear? To the right
Yeah.
side. Okay, towards right side. Toward right side. Right. And we can, apply the concept in this way. For example, 5 Newton force is acting and then 10 Newton force is acting. Yeah. And let's say 2 Newton force is acting from the opposite side. So what will be the direction of the object, right? And what will be the resultant force? Resultant force is given by Rf. Okay, resultant force. Yes. So how we will find the resultant force, beta, this time? This thing is this force and this force. They both are acting in the same direction. They are parallel, so they are going to be added directly. 5
So,
plus 10, it's 15.
and then
Okay,
15 minus 2.
minus 2. Okay, because why minus is there? Because it is coming from the opposite side. So what should be the value?
13.
Yeah, 15 minus 2 is going to be 13. Clear? So 13 Newton. And towards right side, will the object move towards right side or left side?
Towards the right side.
To the right side. Okay, towards the right side. Clear?
Yeah.
Okay, so know that the friction is a force that opposes the motion. Inshallah, in the next class, we will be starting from here. Friction is a force that opposes motion. Okay?
Yeah.
All right. Allah Hafiz. Okay.